This question, I start off by separating the world matrix from the camera matrices by making it its own constant buffer. I create the second buffer here. It's just the size of a matrix. Send the data here, just send it the world matrix. Same result. For the pyramid, it's 5 vertices and 6 triangles starting at the top and going to each corner. So here's the way I made the indices. Also enabled the constructor here. Third question, to have three models rendered. I only have 2 instances here because as part of my further work I refactored this to use the same pointer twice for the 2 pyramids. Here's the first rendered object. It's got its own color and position. Second one has its own color and position, and it's updated here. Third one uses the first pointer again, but it's got its own color and position. For the fourth question, now there's 2 vertex shaders. I encapsulated the creation of the shaders within classes, so it cleaned up the code quite a lot here. This is also part of my further work. So here's the vertex and the pixel shader. Basically makes it active, basically just sets the pixel shader. There's 2 models again. So the models, first 2 of them, get rendered using the first vertex shader, that the color selection, color selected vertex shader. And it binds the second vertex shader that uses the colors from the data, sends them their own individual data, and again uses 1 and 2. The sphere I generate by going vertically to pi and horizontally to 2 pi. Then sine and cosine to generate the coordinates. Generate indices, start from the top pole, then it goes everywhere in between, looking for the quads that compose the in-between triangles in the bottom pole. There's a wireframe version of it. Also enabled this constructor here. Further work, I already showed 3 basically, so I have 2 models declared, but the first one gets rendered twice, but with different positions and colors. Same thing for the fourth one. There's two models only, but they get rendered twice in different locations as well as using different shaders for each set. This is more efficient because now it saves memory due to the fact that the models store the vertex and index data. That's not being duplicated, and it's probably quicker if the same model is not being looked for in different memory locations essentially. The shader process, I created the class here to streamline the process. Here's my class diagram. My design was basically starting here. Every shader that inherits this will share a compile shader. Basically just gets the compiled shader data from the file. The vertex shader is one of them. Here it just creates basically an input layout, which it takes from as a constructor. Basically creates the vertex shader in the input layout. Bind just sets the shader in the input layout. Same thing with a pixel shader. Creates the pixel shader, binds it,